Making new AI data centers in a smarter and more responsible fashion. That's the aim of a new guide for AI data center developers in a collaboration. The Pacific Northwest National Laboratory in Richland worked with industry groups to develop the AI data center energy performance framework. One of those groups involved was the National Electrical Manufacturers Association, or NEMA. To dive more into this guide, we're joined by Senior Vice President of NEMA, Patrick Hughes. Thank you for being here, Patrick.
Absolutely. Happy to be here.
So NEMA specifically focused on electrical systems in this data center guide. From that standpoint, what are some of your recommendations to build better data centers?
Sure. We want to make sure that as these facilities are being built, they're being built responsibly, to be energy efficient and to be reliable and safe for the people that are working in them, and that they're contributing to grid reliability as assets, not liabilities.
Well, can you name some things that data center developers should be doing right now to improve their overall electrical systems?
Sure. We see these new AI data centers consuming as much electricity as some medium-sized cities. And what they can do to limit their impact on the grid and their communities is install things like energy storage and microgrids and generation at the facility, so that when they are training their models and using lots of electricity, they can actually generate that on site and reduce their impact on the local grid. And even in times of peak grid demand, think like a hot summer day, they might even be able to export power and help support the local utility.
A study from your company projects that data centers will consume quadruple the amount of energy they do now in 2035. Can new tech and electrical systems keep up with that rapid increase?
Absolutely, it can, but the pace of data center build out and the pace of innovation have so far been faster than the ability of standards and building codes to keep up with that. And that was one of the reasons why we worked with the Pacific Northwest National Lab and this group called ASHRAE to develop the framework, because we wanted to provide that guidance for what a responsible, energy efficient, safe data center looks like. And that's going to be increasingly important as the pace of data center build continues to increase over the next decade.
Well, we just keep hearing about these concerns, mainly about energy consumption from these AI data centers, as we've been discussing. So break down for me, how can developers build these centers without burdening local power grids and driving up the residential utility bills?
Yeah, focusing on the major energy consumption for the data centers is really key, and that's the cooling piece. And that's where ASHRAE brought a lot of expertise to the table around new, more modern ways to cool data centers that can consume less water and consume less energy in some cases. But recognizing that we're looking at more electricity consumption, not less, how do you do that in a way that doesn't rely on your regional grid? How do you generate it on site and limit the need for the local community to supply that data center with the electricity it needs to operate? And that's what a lot of we call them grid interactive technologies that we lay out in the framework are intended to help do, is help those data centers be more self-reliant so that they're not looking to the local grid to supply that power in every instance.
Well, speaking of, who's helping to design, or what is helping to design and engineer these ground points in your work? Is it AI, or do you see there's going to be a bigger need for electricians and more specifically electrical engineers in America's future workforce?
Absolutely. We need more electricians. We need more engineers. The people who are designing these data centers today, they're doing it in a case-by-case basis in a lot of instances, and it's custom work. And what that means is you're getting a range of different performance levels from data centers, from those that are highly efficient and safe and reliable to those that are less so. So when industry gets together and you have leading scientists from organizations like PNNL talking about the latest industry guidance and the latest building science, you get a very powerful recommendation for how to build data centers reliably and responsibly.
Okay, Patrick Hughes, thank you so much for your time. We appreciate you coming on Washington News Wrap.
Happy to do it. Thank you very much.